Section 3.10 related rates. When solving application problem where we need to use derivative where we have given more than one variable, first of all we need to find out the relation between those variables, and by using the rates of change of one of the variable with respect to time, we can also find the rate of change of another variable with respect to time. These are some tips we can use while solving related rate problems. Whenever it's possible, try to draw a picture. Introduce variable, constant, and remember we're trying to find out the derivative with respect to time. So T stands for the time. So after that, find out equation or information like numerical information like values. And then finally, just you need to find out what you have asked. And usually, you need to find out the rates of change of one of the variable with respect to time while giving the rate of change of another variable. And then, form the equation. And then using that equation, which is actually the relation between the variables you have used in that particular problem, you have to differentiate with respect to t, with respect to time, and finally you will be able to solve the problem. I'm going to do a couple of examples. So let's say first example, when a circular plate of metal is heated in an oven, so whenever we heat the metal, the size of that metal would expand. So now in this problem, the radius of that circular plate is increasing at a rate of 0.05 centimeter per minute. At what rate is the plate's area increasing when the radius is 47 centimeter? So we need to draw a picture because plate is circular, so the picture will be circle like this, and we can introduce variable like radius here, r, and we have given that rate of change of radius with respect to time is 0.05 centimeter per minute, and we need to find out the rate of change of area of this plate when radius is 47 centimeter. And this slash means find out the rate of change of area when radius, this means when radius is 47 centimeter. So to solve this problem, first of all we have to understand, we have to know the formula for the area of circle. Okay, so the area of the circle is pi r square. So to find out the rate of change of area with respect to time, we are going to now differentiate both sides with respect to time. And when we differentiate both sides with respect to time, you can see that you have to find the derivative of r square with respect to time. So we can use chain rule. So the derivative of r square with respect to r is 2r times dr over dt. So pi times 2 times, we are looking for rate of change of area when radius is 47. So plug radius 47 here, and rate of change of radius is given, which is 0.05. By plugging all this value, we can find the answer is 4.7 pi centimeter square per minute. Make sure that because you are looking for the rate of change of area with respect to time, the unit would be area of the excuse me, the unit of this rate would be the unit of the area over the unit of the time. Okay, let's look at another example. 13 feet ladder is leaning against a house when its base starts to slide away. By the time the base is 5 feet from the house, the base is moving away at the rate of 20 feet per second. And these are the three questions we have to answer. So first of all, there is a house like this, and there is a ladder of 13 feet long ladder, which is just standing somewhere here, and then it's sliding down. Now let's assume that the height of this top of the ladder here is h, and then x is the bottom of the ladder. X is the distance of the bottom of the ladder from the house. So when this ladder is sliding down, this x keep grows, right? The value of x is growing now, and then height is going down. So height is changing to the 0 and x is changing to away from the house. So these are the information we have given. Let's try to answer the question. First of all, we are looking for we have given this information. When this distance, when the bottom of the ladder is 5 feet from the house, when x is 5 feet from the house, rate of change of this distance with respect to time is 24 feet per second. It's given here. Now the first thing we have to realize, there is a relation between x, h and 13. We can draw a right angle triangle here. And by using the Pythagoras theorem, we can see that x squared plus h squared equal 13 squared. And from there we can find out the height of that ladder, top of the ladder, which is h squared equal 13 squared minus x squared. When x is 5 feet, we can find out exact height of that top of the ladder by using this formula, which is 13 squared minus 5 squared, which is 144 for the h squared. So h is 12 feet. So when x is 5 feet, h would be 12 feet. We have to use this value later, so that's why we're finding this. So now when x is 5 feet, h is 12 feet, and then rate of change of x is given, which is 24 feet. So the first question is, what is the rate of change of the height of the top of the ladder? So that means, what is the rate of change of this variable h? So now to find out that information, we need to use this equation where we have relation between x and h. Now for finding the rate of change of h, let's differentiate this equation with respect to t both sides. While finding the derivative, we have to use the chain rule. Okay, so the differentiation gives you on the left side 2x times dx over dt plus 2h times dh over dt, and then derivative on the right side is 0. So this is the equation we're going to solve for dh over dt. So we need to bring this term on the right side and then divide both sides by 2h, and because there is a 2 here and there is a 2 here, they will be cancelled out. So dh over dt would be negative x over h times dx over dt. Now for finding the rate of change of height, when x is 5 feet and height is 12 feet and dx over dt is 24 feet, we can apply this value here. So, and after doing the calculation, we are going to see that it's negative 10 feet per second. So the rate of change of height of this ladder, top of the ladder, this distance is going down, it's decreasing, that's why the value is negative. Okay, so negative 10 feet per second. For the part B, we are looking for at what rate is the area of the triangle formed by the ladder, wall and the ground changing then. So we are trying to find out area of this triangle, the rate of change of area of this triangle. We know that area of the triangle is half times base times height. In our case, base is x and height is h. So we are looking for the derivative of a with respect to t. But when we try to find out the derivative both sides, keep in mind x is the function of time and h is also function of time. We need to use product rule while finding the derivative on the right side. So that will be half from here, and by applying the product rule, the derivative of x times h plus x times derivative of h. So now we are going to plug the value of rate of change of x with respect to time, which is given here, times the height, which is given here, plus x, which is given here, and then times dh over dt, which we found in part A, which is negative 10. So by plugging this value and just using our calculator, the answer will be 119 feet square per second. Part C, we are trying to find out the rate of change of this theta with respect to time. For that, first of all, we are going to find the relation. We can use this cosine theta is x over 13. That's the b over h. Now if we differentiate both sides with respect to time, and by using the chain rule, the derivative on the left side would be negative sine theta times d theta over dt equal the derivative of, you can just bring this 1 over 13 times derivative of x with respect to time. Now we need to solve for d theta over dt. For that we need the value of sine theta, and as we know that for that right angle triangle, if you look at that triangle again, theta, there is a 13, there is a 12 when x is 5. So exactly we are looking for the derivative of theta with respect to time when x is 5. That means sine theta is 12 over 13. So by plugging the value of sine theta back here, if you just divide both sides by negative sine theta, this negative sine theta comes on the right side. And after plugging the value of sine theta using this formula, and then after cancellation, the answer would be negative 2 radian per second. Keep in mind, because theta is in radian, so the derivative of theta with respect to time, the unit is always the ratio of the unit on the, of the variable on the top and variable on the bottom. So the theta is decreasing, theta is going down as height goes down. So one more problem. A spherical balloon is inflating with helium at a rate of 200 pi feet cube per minute. So remember, it's a feet cube per minute, so that means it's a rate of change of volume. Now question is, how fast is the balloon's radius increasing at the instant the radius is 5 feet? And then second question is, how fast is the surface area increasing? To solve this problem, first of all, we have to know the formula. If you have balloon like this, a spherical balloon like this, then volume of this spherical balloon can be found by using this formula, V equal 4 over 3 times pi r cube. And the surface area of this spherical balloon can be found by using 4 times pi times r squared. Now these are the formula, and this is the thing we have given. The rate of change of volume with respect to time is 200 pi feet cube per minute. And these are the questions we need to find out. What is the rate of the change of radius with respect to time? And what is the rate of change of the surface area with respect to time when the radius is 5 feet? So to find out this information, we're going to take this equation, this formula, differentiate both sides with respect to time, and we use the chain rule. So we start with the volume first. When we differentiate both sides with respect to time, we get dv over dt equal 4 over 3 pi 3 r squared times dr over dt. Now we need to solve for dr over dt. For that, we can just divide both sides by the leftover thing from here, which is 1 over 4 pi r squared times dv over dt. Now since we are looking for these changes when radius is 5, so we're going to replace this r by 5 square, and the rate of change of volume is given, which is 200. So after doing this calculation, we're going to get answer 2 feet per minute. That's the rate of change of radius. And for finding the rate of change of surface area, we need to use this formula, differentiate with respect to t, and then by using the chain rule on the right side, we're going to get 4 pi 2 times r times dr over dt. And we're looking for this rate of change when radius is 5, so plug r equal 5. And then the rate of change of radius with respect to time from previous part is 2 feet, so we're going to plug that value back here, and after multiplying everything, the answer would be 80 pi feet squared per minute.